now. Okay, I cannot open full screen because I do believe a lot of others will try to join after this, so I need to reopen my Google Meet to accept. Okay, now, yesterday we did take a look into latches. Before we go for latches, we did see what is combination and also sequential circuit. What is the biggest differentiation between each other? And you already take a look that the biggest differentiation is when you can see here sequential logic got a memory. So the output for the sequential logic will be depend not only for the input but also the previous output. So that is the first keywords that you need to remember about your sequential circuit. Next, in terms of your sequential circuit, what you how many categories that you can divide it? So you have here event driven, clock driven, pulse driven, all of these. You can see the detail on the top here. Okay. How many? No, still not full. Okay, so we can categorize them into three, which is event driven, clock driven, and pulse driven. We have event driven for asynchronous, clock driven for synchronous, and pulse driven is the combination between event and also clock driven. And for clock driven, it still can be categorized into two, which is cyclic and non-cyclic. That is a very basic thing, and normally, although it's basic and it's going to be asked in your multiple choice question for part A for your final exam, you need to remember all of the details. And about the latch, what type of latch that available? SR latch, get SR latch, and I already mentioned yesterday, get SR latch is not equal to the ESR latch. What is the biggest differentiation for the get SR latch? We got the EN. We got the EN there. If you want to check the recording, you can just go to my YouTube. Sometimes I didn't have time to copy the link from YouTube to your e-learning, but I already uploaded all the video to the YouTube. Okay, wait. Okay. Yesterday we did finish cover all the latch that available. SR latch, get SR latch, and also another one that I already mentioned is quite easy if you compare to others, because you need to remember only small part, especially for the input trigger for the tables and the get D latch. And today we're going to go deeper for our flip-flop. Okay, I think there is no other going to join us, so maybe we go directly. I'm going to make full screen. Okay, I'm going to do recap first. Let's see what is SR latch. Here S is for set, R for reset, D for data, and yesterday set you already know that your output will be 1. Reset, your output will be triggered to 0. And these all informations about Latch you need to remember, because it's going to be also coming out for your final exam. I'm the one who create the module 7 and module 8E for final exam. So yeah, please make sure you know all the theory. And about the SR Latch, we have active high and active low. What is the difference? The big difference you can see here, there is a bar and there is no bar. And if in the block diagram you can see you have the bubble thing here. Sometimes in the equation it's not going to mention active low, but when you look into the logic symbols that represent in the picture, you already know, okay, this is active low. And yesterday I already derived everything here. What you need to do is you need to remember the table for active high and active low at this slide here. And if you argue how come this can be like this, how come it can be like this? So yesterday we already derived one by one all the input following the circuit given. So we put the 0, 0, 1 or whatever input that we given similar to this table, then we already derive, we finally get this table. For the active high, you can try also to derive for the active low. So this is all the informations basically on the derivation and the informations about this table. But you can see here there is invalid condition. Why it's invalid condition? We did not just assume it to be invalid. It's be invalid when you apply all the derivation inside here. You're going to get Q and Q bar is similar value. Which is 0 and 0. That's why we say it's invalid, because supposedly Q and Q bar is toggle to each other. So please try to do, if let's say you don't know how to do it, you can draw this. I think yesterday I'm quite busy develop the final equation. So a lot of you yesterday WhatsApp me, and I don't know whether it is come from this section or not. One of the students asking me about let me check my WhatsApp about from the slide for multiplexer. So she asked me how from many input we finally get only 4 input, and at that slide you have only like a small table like this, the final table. So what can help you, because if you can see for your multiplexer, you're going to have 1 of 4. You're going to have many inputs there. And in the slide you have 2, 4, 6 input. So of course it's going to be very big to have 6 input for you to draw the table. If you're really patient, you can do it one by one and fill in the input value into your circuit for the marks, the multiplexer circuit, because it's already given. And you can derive, finally you will get the tables. the final table, your S1, S0, 0, 0, 0, 1, 1, 0, 1, 1, and your Y will be D0, D1, D2, D3. How you can get this to the conclusions like this? So you need to derive it one by one as I did in our class, you can see. So you need to derive it also into the circuit. When you derive, then you can see, oh, you will get this. If you don't want to do it because it's too long, what you need to do, you just draw the circuit, whether it is marks, D-marks, or whatever circuit, you draw, and then you key in the input value, you construct the table, you key in the value, and you can directly go and get the output, right? Rather than you can like putting it manually, what will be this output, what will be the output. So you use this simulator, you will get the output directly, you compare, and of course you're going to get similar thing for the conclusion. If you don't want to understand, you can just memorize the table. Now, let me proceed. Okay, this is example we have done yesterday. The video I already uploaded to the YouTube. Only that I still not yet updated in your e-learning, I guess so. How are you going to do? That is under SR. Okay, let me show you one example here. When you have bar here, of course, you already know it is active low, and the initial value will be given low also here. Remember that your table is for SR Latch, you have SR and then Q 0, 0, 0, 1, 1, 0, 1, 1. For 0, 0, it will be invalid. For 0, 1, it will be set. For 1, 0, it will be reset, and here will be no change. When you remember this table, you apply into your timing diagram. It's easy for you to draw the output. If you didn't remember, then it's going to be hard for you. So if let's say for this case, I already asked you to do the step-by-step. First step is, there is a lot of you want to join, but I want to explain this first. First step, you need to draw the dotted line. Second, you fill in the value inside so it's easier for you to compare. Third, you draw the output. So at this part, you have 1, 1, 0, 1, 1, 1. Don't do this fast away because I asked you to do the dotted line for every changes, right? But this one we did yesterday, so I'm going to speed up. Okay, here I have 1, 1. There is no change, so it's going to be initially low. 0, 1, I'm going to go for the set, so it will be 1. And here 1, 1, no change. 1, 0, it will be reset. Sorry, at this part. 1, 1 again, you can see here. Yesterday I already shows you, although it is small changes here, but you need to consider also to check 1 and 1 is going to be no change. That's why it's directly go here. You have at this part 0, 1 to be set. 1, 1, no change. 1, 0, reset. 1, 1, no change. 1, 0, reset. 1, 1, no change. 0, 1 is set. 1, 1, no change. 0, 1 will be remain. So this is how you draw yesterday. If you still confused, you can watch back the video for our class yesterday. Okay, shall I continue? After we have the SR latch, the thing that I said, it's very important for you to remember only for the table there. And you need to understand how to apply this table into the timing diagram, into the table there, whether it is set, hold, reset, hold. Maybe you can also mention about no change. Basically it's similar. Kenapa bila I full screen baru ada nak join? Okay. Next is about your get SR latch. If you still remember, the important things is when you have the EN. So you have 3 input now. EN is like your switch. When EN is 0, nothing will be changed. No change, although this one is changing in the value. It still remain the same following. Apa yang same? What is the same? The similar is going to similar for your previous output. If previous output is 0, it's going to be 0. If previous output is 1, it's going to be 1. If it is EN equal to 1. But when EN is 1, then you need to consider and look into the SR, which is totally similar. The table, you can see here, the table is similar to your, if let's say here is your active high, the table will be similar to the active high. So you just need to look into, if it is 1, then you need to consider your input. If it is 1, you need to consider your input. If it is 1 all here, so you need to consider your input. For the rest, for 0, 0 here, you just follow your previous output, previous output, previous output. Another one, latch, the last latch, which is I mentioned yesterday, it's very easy because that one is much more simpler. It will be your get D latch. The difference is you only have one input there with the N. N is the similar function when you have En equal to 0, nothing changes, no change, or it holds. And for En is equal to 1, then you need to check your input. Now your input is only 1, and it's very easy. If D equal to 0, it is similar to 0. If D equal to 1, your output will be also 1. That is very simple and easy for you to draw the final output. Okay, any question about your latch before I'm going to proceed with the flip-flop?
No question, Doctor.
Okay, thank you. So we're going to directly go for our flip-flop. What is happened with our flip-flop? What is the differentiation between our flip-flop and also latches? Yesterday, if you still remember, I did mention one thing make different between your latch and also flip-flop when you have this thing. This thing for active, for positive trigger, this one. I don't know whether you're familiar or maybe you already look into, maybe you already study before the class. So this thing we call as clock. When you have this symbol, you have last time your latch SR. And if you have the N here, you have N. But when you have something like this or something without the bubble there, this is clock. And this is the only things that you can say, okay, this one is flip-flop. Although you can see you has quite similar SR flip-flop. Last time you have the SR latch. But when you have a SR flip-flop, the things that different when you have the clock. Last time you have also get latches, which is you have EN there at the middle of your block. But now when you have flip-flop, you're going to have the clock. So let's take a look into SR flip-flop, H trigger, D flip-flop, Jk flip-flop, and toggle flip-flop. Normally, the frequent use flip-flop is Jk flip-flop. Okay, that's the keywords for you. I guess you can read and go through one by one, but I'm going to be directly informed about flip-flop. You can see flip-flop are synchronized by stables. This one also is very important, and you can see there is a trigger. Last time our trigger for our latch is EN. When EN is 1, it's going to be trigger and look into your input. But for flip-flop, the trigger is a clock. And just now I show you the two symbol. One got a bubble, one didn't have a bubble. So all of this is referring to this information: rising edge or positive edge, and falling edge and negative edge. This one also I think I already give a teaser last time. Let's take a look. Okay, you can see here, this is your positive edge, positive going pulse. And sometime in your timing diagram, you're going to be given with the input, isn't it? Normally, you're going to be having the input, whatever input that you have, let's say S and R. And you're going to have a clock. Just now for latch, you have EN. For clock, you're going to see it's very, what we can see, repeating wave. So here, at this clock, it's going to be draw something like this, an error. So if it's draw pointing up, it's going to be all pointing up. There is no just this thing. One is pointing up and then suddenly here is pointing down. One is pointing up, suddenly here is pointing down. No, because if it is pointing up, we call it as positive going past or positive clock. Positive clock will happen here only at this side from low to high. While if you have this kind of clock, the error is pointing down. It's not at this side. Okay, I already mentioned yesterday. It's going to be pointing down there. It's called as negative clock or negative going pulse, or another one is what? Falling edge. So the error will be pointing down. And in terms of the symbol, you can see here, you got the bubble there. So please make sure you remember what is the difference between each other. And you going to have, yesterday I already mentioned, kat mana I nak conteng ni I cari space. Okay. Let's say yesterday we have EN. Kita ambil only one D, let's say. I have this kind of waveform for my D. Okay. And my EN. Let's say this is my EN. And if you still remember, you're going to change and look into your input when this is 1. So starting from here, it's going to look into your input side. So here it will be change. If D is 1, your output will be 1. For 0, it's no change. And then here is will look also up and no change. Look up. Here you can see it's going to be pointing down and no change. Oh, sorry. Here will be look like this. But if you have the clock, this one is on the latch when you have EN. But if you have a clock, it's not going to see whether it is 1 or 0, but it's going to see at the arrow there. At this arrow, you need to see it going to be triggered and look into your input. So it will change at this only. At this, you're going to look into. At this clock, you're going to look into your input. And that's one is for a positive clock. If you have the negative clock, you're going to have this kind of arrow. And at this side, you need to look into your input. At this side, you need to look into your input. At this side, you need to look into your input. Not here, not here. It is at the specific arrow part. Not here, not here, not here. You need to look into only at this part. Look into your input. Then it's going to be your trigger following your input. So that is the difference between EN and also your clock. So let's take a look here. You can see here we have the clock for our SR flip-flop. Then you can see the differentiation. We have SR, we have latch and flip-flop. If latch, you look into the EN there, 1, 1, 1. If clock, if flip-flop, we're going to look into the clock, the positive clock there. Okay, let's take a look what happened for our latch first. For our latch, we're going to have SR latch. This one is positive, I guess so. And our Q starting point is initial to be 0. EN equal to 1. If you still remember, if 0 SR 0 0, it's going to be no change. 0 1 is going to be 0, which is reset. 1 0 will be 1, which is set, and 1 1 is invalid. Okay, now set in your mind, we're going to look into latch only at this part. Okay, here there is no change at all until this part because everything is 0 0 0 0 0. And when we're going to change, we're going to change when it is 1. So look at the one side there. At this one, we have set as S as 1 and reset as 0. 1 and 0 is going to be 1. So you're going to have 1 there. Until this part, you can see 0. So no change until here. You can see there is another things. For this part, okay, as I mentioned, for latch, you need to draw all the the dotted things at every single changes. For this reset here, you can see here is changed to be 0, 0, here is 1, here is 0, 0, 0. Okay, at this side, at this one here, you look into the first thing, you're going to have 0, 0. 0, 0 means no change. That's why it's follow here. For this part, as 1 there, you can see the input is 0, 1. 0, 1 means it's going to be 0. At this part, there is another changes which is 0 and it's going to be no change. So it's going to be no change until you meet another 1 there. Your 1 here is 1 and 0. 1 and 0 is going to be 0. And at this part, no change. This is your latch. For your flip-flop, so for your flip-flop, you're going to see at the trigger clock only. You can see just now latch, you have all these things to see the difference and consider your input. This all thing there, you need to check your input. This all thing there, you need to check your input. That's why just now here at this part, you have these two kind of input, which is 0, 0, and another one at 1 for EN, you have another 0 and 1. These two at this EN equal to 1. So that's why you have two things. One is 1, another one is 0. 1 will be a 0. Okay. So our clock, we're going to look into only at this rising up. For rising up there, at the specific this line only, not at all input 1. Not here like our EN, but at this line only, we look into the value 1 and 0. 1 and 0 is going to be 1. So that's why we're going to trigger to be 1. And it's going, not going to see any others because it's going to be only look into specific this point, as I mentioned. So it's going to be continue until another next rising up there, another positive clock. So at a specific this point, it's going to be 0 here, and then here is 0, 0, and 0. It is no change. No change. You will go directly to another rising up. So in between, although you can see it is 1 here, it's not going to look into until another clock trigger. At this specific, you have 1 and 0, 0 and 1, we have 0. So you're going to trigger to be 0. So here is the part you can see it is totally different. Although you have similar input, but your latch and your output for your flip-flop is different. You can see is totally different, because Latch is looking at this EN is all this one part. If this one is bigger like this, you're going to look also into all these changes in the value. If let's say here it's 0, also you need to consider all the things at these changes. But for your flip-flop, you just look at the single one line, at the clock only. If it is a positive clock, at this side, and if it is negative clock, you need to look into only at this side. So you need no need to look into this, all the because you don't want to look. You just look at the single one line. This one is positive. If negative, at this part only. Look into the value at the certain line only. Okay, any question? So you can see now your differentiation between latch and flip-flop. What here? Okay, this one is one by one explanation, which is similar to what I showed you just now. This is the explanation for the latch and the flip-flop.
Doctor?
Yes?
For the flip-flop, I don't understand why it became 0.
Which one?
In the end. Here, yeah.
Okay. Let me see at this part. Okay. For this part, at this specific point here, our set is 1 and our set is 0, and our reset is 1. 0 and 1. And our 0 and 1 will be reset, right? Reset, yes. Supposedly, where is the table? Just now.
Oh, we refer to the table actually.
Yes, we refer to the table exactly similar, which is you have R 0, no change, 1 will be reset, 10 will be set, and 11 will be invalid. So you're going to refer similar, but it is looking at your clock. For latch, it is your EN, right? Now for flip-flop, it is at the clock. So if here is 1, 1 will be reset. That's why you go down to be a 0. Okay.
I see, Doctor. Thank you.
Okay, thank you. So now you need to also remember the table for SR flip-flop, but it's basically similar. Here you will given also. Where is it? This one. Which is I already mentioned just now, it is totally similar. When you have 0 and 0, 0, you're going to have no change. 0, 1, you have reset, which is go to 0. 1, 0, you have set, or 1, 1, 1, you're going to have invalid. Which one? This, the different now is clock. Last time for your latch, it is the EN. So now it is clock. Either it is a rising up positive clock, it is an or negative. The table is similar. So let's see another example here. We have SR clock, and still remember SR, like we have clock here. If 0, nothing changes. If there is a trigger, now is our positive. You can see positive, which is rising up, rising up, rising up. We have 0, 0, 0, 1, 1, 0, 1, 1, and our output will be no change, reset, set, and invalid. Referring to the table, we will look only doing the dotted line from your rising up clock only. So the dotted line already done. So at this specific point, my input is 0 and 0, 0 and 0, no change. So here you can see no change. It will follow directly without looking anything after that. Although you can see this is a value of 1, but no need for you to look. You're going to look into the next line here. Here is 0, here is 1. 1, 0 will be 1. So it will be set. And it will continue until your next trigger. Your next trigger is 1 and 0. 0, 1 will be reset. Reset there, you can see. So you continue until your next trigger 0, 1. 1, 0 will be 1 or set there until your next trigger clock there. You can see it will be 1, 0, 1, 0, still 1 or set. So that is your output. So here you can see it is a positive edge trigger. Or it's not explaining. Okay. Now you have another example. Let's redo it one by one. And you can see it is SR flip-flop. Find the output of Q and Q bar. This one doesn't matter because it's just a toggle for your Q. So as long as you know the Q value, of course, your Q bar you can toggle only. Assume that it is a positive edge. It's already mentioned there. You can see positive edge. And as always, the initial value will be given. The flip-flop is initially reset. Reset means 0 or low. So our initial is given there. And look into at this dotted line only. For this dotted line, I'm going to put the value. Here will be 0, here will be 0, here will be 0, here will be 1. This one is 1 and 0. This is 0 and 1. 1 and 0, 1 and 0. So I still remember my table. No change for any other than positive. Here is my output. 0, 0 will be no change. 0, 1 will be reset. 1, 0 will be set. 1, 1 invalid. So let's withdraw the output from initial as a 0. At this point, it is 0, 0. 0, 0 is what? No change. So I just directly draw until my next dotted line, which is at my positive clock here. So at this line, my next input is 0, 1. 0, 1 is reset. So it is still maintain 0 until my next dotted line for my next trigger clock. So here will be 1, 0. 1, 0 is set. So I'm going to draw up until my next clock positive. Here is 0, 1 is reset. I draw like this. Here is 1, 0, 1, 0 will be set until the next one. Here is similar. So this is my output of Q. And of course, the Q bar will be just a toggle from my Q. So this is my output and my answer. I think it's slightly much more easier if you go for lectures. You need to check every single detail in this input EN. If it is 1, right? So every changes you can see, oh, there is several changes there. So you need to see if at 0, 0 what happened, at 0, 1 what happened. So you're going to have several changes there. But for clock, it's much more easy because only at this specific point only. At this specific point. At this specific point. If it is positive, at this side. If it is negative, at this side. Okay. So this one is similar, the explanation just now, but it is in terms of the table. You just copy paste it back. No change here. Reset, set, and etc. And now that is under our SR flip-flop. We have next is our D flip-flop. D flip-flop, the things is quite similar just now with our latch, but only you can see the EN now is the clock. That is the only different. And normally we can say it as a data or a delay. Let's directly look into. You can see here. This is basically similar. You can see 1 to be set, 0 to be reset. For latch and also flip-flop, the flip-flop also having the similar table. The different only last time for the latch you have EN, which is 1 and 1. But for the clock, you have whether it is falling up and falling rise or rising up or falling down. So it's depend on your clock. Positive clock like this, negative clock like this. Okay, and you will change only at this line. You can see here. At this line, you look into the value of D. The value of D is 1. So you're going to have 1 until another next clock. At in the middle, in the between, you're not going to do any changes. At this one, you can see, oh, D is 0. That's why it's 0 and nothing will be changed in the between until you meet another clock there. This clock, your D is 1. Of course, your output will be set also as 1. Until the next, there is no changes at all. At this specific, you need to check the output of D, it is 0. So that's why you will get like this. Easy, right? If compared to your D latch, clock is much more better. Now we have new thing which is JK. Last time at our SR, our latch, we don't have JK latch. But for our flip-flop, we have a JK flip-flop. JK flip-flop is versatile and is widely used type. As I already mentioned just now at the beginning of our class, normally the most used flip-flop is JK flip-flop, widely used. The difference between JK and SR, what is the difference? So you can see you can compare basically what is happened to your SR latch and also JK flip-flop. But here, let me proceed with the next. JK has no invalid state. That is the biggest difference with SR. SR got what? For positive SR, you have 1 will be invalid. But for and then for negative, you have 0 invalid for SR lah. But for JK, there is no invalid. That is the biggest differentiation between JK and SR. So let's take a look on the table. 0 no change. Oh, similar to SR. 1 reset, similar to SR. 10 is set similar to our SR, but the only difference is at this one, 1. For SR, it will be invalid, but for JK, it will be toggle. What mean by toggle? If your previous output is 1, then you're going to toggle your value of the output Q will be 0. If your previous Q is 0, then your output will be 1. That means by toggle. Not too hard, right? This you need to remember the table. Okay, let's check the example here. We have the JK flip-flop. We need to remember, come out with our table here. We have positive. Now is our positive, then it will be at this side only. Oh, banyaknya. So only at this side, we're going to look at the changes. So here, 0, 1. Here, 1, 1. Here, 1, 0. Here, 1, 1. Here, 0, 0. Here, 0, 0. This one is also 0, 0, 0, 0, 0, 0. Okay, done. I already do the dotted line for my positive clock. This one, there is no changes in between, also no changes. Let me draw our output. So here 0, 1. What is our 0, 1? 0, 1 will be reset. This is initial value of our Q. So reset will be remain 0. Remain 0. And of course, I said just now, there is nothing changes after that until you meet another clock. This another clock, we have 1, 1. 1, 1 is what? Toggle. Look into previous output. Previous output is 0. We toggle it to be 1. So we continue directly to another next clock. 1, 0 is going to be set. Set will be 1 until the next clock. 1, 1 will be toggle. Toggle is what refer to your current output now. It is 1. So we're going to toggle. If 1, we're going to change this to be 0. Directly go to the next clock there. 0, 0, no change. Directly go and meet our next clock. No change also. Here is also no change. Here is also no change. Here is also no change. This is our output. It's like makan kacang. It's too direct, isn't it? Too easy. So here another example, okay? I have this another example. Flip-flop. Already given the picture. This one is positive. Because there is no bubble, positive will be like this. Not here. Don't put at all. It is only at the rising up. This part, this part, this part, this part, this part, this part, this part. And luckily, the dotted line already helped me. And initial Q is low. So I put the initial is low. And at this specific dotted line, which is at my positive clock, I'm going to put the value. See, last time for lectures, I have to put every single changes at the input, but now it at the specific line only. I have here 0, 0. At this, I have 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, and here is 0, 1. Okay, remember back our table. We have Jk and also clock. Okay, we assume it's to be all positive. 0, 0, 0, 1, 1, 0, 1, 1. There is toggle here. Here will be set. Here will be reset. Here will be no change for the Q. So our output will be 0, 0, no change. So no change until the next dotted, our next trigger. 1, 1, 1, 1 will be toggle. If it is 0, I'm going to make it as a 1 until the next clock. 0, 1 will be reset. So I'm going to be reset until the next of trigger. 1, 0 will be set. Set. Another 1, 0, set again. 1, 1 will be toggle. So from 1, I'm going to go for 0. 0, 1 is reset. So it's going to be reset. This is my output of Q. And if you need to draw the Q bar, then it will totally toggle everything. So this is the answer. So you can try without looking at the answer. Try first and compare with your answer. There is another example, but now you were given with negative. So you need to draw the negative clock. And initial is low. Draw the table. I hope that you can remember the table. Jk 00011011 toggle, set, reset, no change. We have here the value is 110001. Correct me if I'm wrong, okay? 1010. Okay, now 1 toggle means that from 0 I'm going to go for 1 until the next negative clock. 0, 0, no change until the next negative clock. 0, 1 will be reset until our negative clock. It will be 1, 0, 1, 0 will be set, and 1, 0 again will be set. So this is my output. And you cannot change at this side, okay? You cannot start from this because this is positive. You need to trigger only at this side. Although maybe your answer is like similar because you can see you only make a changes like at the positive side, although it already shows you it is a negative. Although it is similar, but your answer will be wrong. Okay, although the wave is look like similar, but at the specific time you trigger at the wrong specific time, you're going to have 0 because it is wrong. And another last one, I think last one, okay, the T flip-flop. Okay, our T flip-flop. What is happened to our T flip-flop? T flip-flop normally also known as a toggle flip-flop. Toggle flip-flop, and you have this, mana pen I? This table. If you have zero, if you have zero, you're going to have whole. Zero, you're going to have whole. All whole means no change. No change. When you have one at your T, it will be toggle. That is only things that you need to remember. So you can assume it's to be, mana I punya pen? T, you are the clock, you have got clock, maybe a positive or maybe it is a negative, it's depend. Positive or negative, positive or negative. And your clock will be, I have two only. 0 and 1. If it is 0, no change. If it's 1, it's going to be toggle. So this is the table that you need to remember for the T. So referring to this table, let's we get the hour output. Here is our negative clock. That's why we look at this point only. And for this point, we have the T is 0. Here is 1. Here is 0. Here is 1. So for the 0, no changes. It will go directly to the next toggle. Next clock. Here is 1. It's going to toggle. This will be toggle until the next clock. 0 means no change. This will be directly to go to the next clock. 1 here is toggle. If from 1, it's going to be 0. So this is our T flip-flop. Okay, any question? Because we already finished with all the flip-flop. We have covered our SR flip-flop. We already looked into our Jk D flip-flop, and then our Jk flip-flop, and lastly our T flip-flop. Any question?
No, Doctor.
Okay, understood, right? So let's we proceed with I think last subtopic for synchronized and unsynchronized. You will look into the pre and clear. This is the thing yesterday, if you still remember, I already mentioned about this thing. You're going to have a lot of input. You have need to consider with your pre and clear. And yesterday I show you the table, the priority table. Okay, synchronized and unsynchronized. Async, preset, and clear input. This is clear, this is preset. And if you have this thing, you need to consider this first. If the pre is 0, the clear is 1. Kenapa dia tak ikut curutan? Let me put the incorrect order. If it is 0, 0, it will be invalid. If it is a 0, 1, it's going to be set. Or unsynchronized. It will be set. Your output will be follow the flip-flop as a set. And then for your 1, 0, it will be reset. This is all your flip-flop output later on. But when you have 1 and 1, then it is unsynchronized. What the meaning by synchronized mean? You need to look into the flip-flop inputs. If it is JK, then you need to consider on the JK part. If it is a D, you need to look into the D flip-flop. If it is a T, you need to look into the T flip-flop, and etc. Let's take a look into the example. So the priority, which first you need to consider? First, you need to look into the value of pre and clear. That's why you need to remember the table. Invalid 01 is set, 10 is reset, and 11 is synchronized, means that you need to look into the flip-flop inputs. This is the first thing that you need to look, priority, and second, you need to look into your clock, and lastly, at your flip-flop, which is synchronized input. You can go through and read this. Also this table, but let me teach you how you're going to look into at the example. Now you can see here, this is your pre and also your clear with the value already given here. And this is Jk flip-flop. Your J and K is directly meet the H. Okay, if you still remember, let we draw one by one Jk flip-flop. It will be 0, 0, no change. What else? 0, 1, reset, 1, 0, set, 1, 1, which is supposedly invalid for the high. And assume our Q will be low. You can see here, assume our Jk will be low. Find the Q wave. Okay, this is our Q. Okay, now, first of all, you need to check this value. What value? Pre and clear. If pre and clear, for the Jk will be 1 is similar to the toggle things. Later you will look into, Jk there is no invalid, sorry. This one will be toggle. Toggle, right, Jk. I also already confused. So you need to remember, okay, Jk, this one is toggle, sorry. This one is toggle 1, 1. Okay, now we have the Jk table. We need to come out with the pre and clear table also. Pre and clear. 0, 0, no change. 0, 0. Where is my preset? 0, 0 invalid. 0, 0 invalid. 0, 1 is set. 1, 0 will be reset, and 1, 1 you need to look into your table here. Okay? Because it is synchronized. Now let's take a look one by one. I need to use different color. Maybe this one. Okay. First, you need to consider this part. Second, you need to look into your clock. And lastly, your Jk, following the order of this priority. First, you put the value. Here is 0, here is 01, here is 01, 1, 1, 1, 1, 1. And this is 1, 1, 1, 1, 1. And here is 0, 0, 0. And second, you need to look into your clock. Because it is a positive clock, you need to change at the specific, this line only. This is a positive clock. And let's take a look into the input of pre and clear. Pre is 0, 1. 0, 1 is set. Initial is 0. From 0, I'm going to go to the set. Oi, So at this part, I'm going to set. Here I got 1 and 1. 1 and 1 is going to look into your 1 and 1 is going to look into your synchronize. Here you can see, this is not 1. It will be sorry, this one is 1, this one is 1, this is 0. Betulkanlah. Okay, 1 and 1. Initial is 0. Initial value is 0. And at this side is going to be changed because there is a changes at your pre and clear. As I mentioned, you need to check your pre and clear first. Then baru you going to look into your clock. At this part, you have 0 and 1. 0 and 1 is going to be set. That's why from low, you're going to be set. You look at this point, there is no changes. 0 and 1 will be set. 0 and 1 will be set. 0 and 1 will be set. Until at this part, it will be triggered at the changes because here is 1, here is 1. 1 and 1, you're going to look into your synchronize, which is your flip-flop. So for your flip-flop, you can see 1 and 1. You're going to look into your flip-flop at your positive clock here. Here, there is no changes yet until you meet the clock because 1 and 1, you need to look into your Jk flip-flop, which is your Jk flip-flop. You're going to look into your positive clock first. 1 and 1 for your preset is going to be synchronized looking at your flip-flop. Flip-flop is positive clock here. Here will be trigger or changes. 1 and 1 is going to be toggle. Sorry, this one is Jk. Yeah, Jk is 1 and 1. You can see here, it's going to be toggle. And you're going to have all the value is until this part. All here is 1 and 1 means that is a synchronized. Synchronized means you need to look into your flip-flop, which is at your positive clock because your flip-flop is positive clock. Next changes at this side. It's going to be toggle. Why? Because your Jk value is 1 and 1 because it's high. You can see. So if you are given with the Jk value here, you need to refer to the waveform. But it's directly given. It is 1, 1. Of course, you're going to see directly at this part, which is toggle. So now it's changing from 0, it's going to be toggle to 1. At this clock also, it will be toggle to be 0. And at this point, it's going to be toggle until at this, you can see pre and clear is changing the value. 1, 0 for your pre. 1, 0 is what will be reset. So you're going to reset. This one is also reset. This one until the end will be reset. This is your output for your Q. So there is several things that you need to consider. First thing, you need to consider look into the pre and clear value. If the value is 0, 0, 0, 1, 1, 0, it is all asynchronous, mean you need to look into the value. 0, 0, no change. 0, 0 is, tengok I lupa lagi. 0, 0 is invalid. Invalid. 0, 1 will be set. 1, 0 will be reset. And if your value over here, you can see at this side is 1, 1, you need to look into synchronize, which is referring to your flip-flop. You go back to your flip-flop, which is positive clock. Then you will have the changes at the positive clock only. And our value of Jk here, you need to have the Jk 00011011, Jk 00 no change, 01 set, reset, set and also toggle. And our value now is 1 always because it's directly given. So we will toggle every value at the clock there. And when there is a changes at the value of pre and clear, you need to check and consider the changes. So next is what else? This one is explanation, similar things. That, it's going to explain whatever we done just now at the value here. And we have another example. Okay, for this one, pre and clear, find the waveform assumed to be 0. Where is the clock? It's been give a clock. Supposedly it's going to be, okay, because it's already give the dotted line, I think it's going to be at the positive. Supposedly in question it's going to be mentions whether it is a positive or negative. If it is not mentioned, it's going to draw you the symbol. So here you need to see the changes at the pre and clear first. This is the changes at pre and clear. Here will be 1, 1, 0 until here. This is 1. For our pre and clear, 0, 0 invalid, 0, 1 is set. Correct me if I'm wrong. There is too many now. Reset and 1, 1 will be synchronized. So here we will refer to our pre and set. At this part is 1, 1. You can see this is 1, 1, 1, 1, 1, 1, 1, 1. So all the thing at this side, you're going to look into your flip-flop. And then after that, at this side is change the value 1, 0, 1, 0, 1, 0. Is it similar question? Now we have here at our initial is 0. For 0, 1, 0, 1 is going to be set until the next changes of your pre and clear set. Until this part, you can see at this, you're going to look into your flip-flop. But flip-flop, you're going to change only at the whether it is a positive or negative clock. Now our positive clock here, Jk value also is not given. I don't know what happened this question. Maybe we need to refer this or similar things. So we assume it's to be high, both it's going to be toggle at this side. Toggle, toggle, toggle until here. It will be 1, 0. 1, 0 will be reset. So this is the solution. Please try to do, then you can see the it clearly. And now I mentioned you can see now it's give you the waveform. Just now it didn't give you the waveform because the value of Jk is already directly fixed at 1, 1 only, which is toggle. For this example, you were given with the value of J and K. So draw one by one, don't be panic. Negative edge trigger. Okay, it's already give you negative edge trigger. You draw first the negative clock. Okay, done. Settle for the negative edge. Initial value is high, so you start with the high first. And okay, that is the only things. First thing, pre and clear, 0, 0 invalid, 0, 1 set, 1, 0 reset, 1, 1. You're going to look into your flip-flop or synchronize. This is all asynchronized. Synchronized means you're going to look into your JK. JK refer to your clock, CLK. Now it's negative, 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 0, 0, 0, 1, 1, 0, 1, 1. Toggle, I hope it's correct. It will reset, and no change. Please check this one, okay? I can't remember. This is your output. This is your output. Okay. We already have the table to refer. We need to look into at our pre and clear. So every changes at our pre and clear, you need to draw the dotted line also. Just now you can see it's directly give you the dotted line because it's no. Okay, this question already know the answer. But for us, as I already mentioned, we don't know. So first thing we look at our pre and clear. Whatever changes, we're going to do the dotted line. Here is another change. There is another change. And here is the value of 1, 0. Here will be 1, 1. And the rest of here is 1, 1. You can see here. And remember, at 1, 1, you're going to look into your clock, which is referring your flip-flop, which is referring to your clock and also your JK input. Okay, we done this part. Next, we move to here. We have 1, 0, and again, here we have another 1, 1. We have another 1, 1. And another 1, 1 here. If 1, 1, we need to look into the flip-flop. Here is the value of 0 and 1. Okay, we done putting all the value, but still the JK also we need to put the value, but the value at the specific single line only. At this side, my J is 0, my K is 1. At this side, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0. Done. Everything is done. My turn now is to draw the output. Okay, first thing, the parity. I need to check my clear and pre. At this side, my clear and pre, of course, this is initial, 0, 1. It doesn't matter because it's going to be set high first. And then it's directly go to my 1, 1, synchronize. So I need to go to my clock. So at this side, nothing changed until I meet my clock. My clock now is negative. At this side is 1, 0, and 1. 0 and 1 is reset. Reset, I draw to the down until I meet another clock. Why? Because this is all 1, 1 for my pre and set. free and clear. So I need to refer as a normal JK flip-flop. So at this negative, I have 1 and 1. 1 and 1 is what? It's toggle. So I'm going to toggle my value until I meet another one is 1 0. 1 0 is set. So I'm going to have set. And after that, I have here 1 0 again. It is set until I reach at this part. You can see there is a changes of value for my pre and set. Now it is 0 1. 0 1 is going to be set again. So I just continue with my set. I hope my thing is correct. Please check if I did wrong here. Please correct me. The table especially. Now I have this thing. I need to refer back to my flip-flop. I'm going to change only at my trigger clock. So I continue until I reach to my clock here. My clock is 1 0. 1 0 is set. Another clock is 1 1. 1 1 will be toggle. This one is 0 1. It will be reset until I reach 0 1. 1 0 for my pre and clear. It will be reset. And here will be following my flip-flop. I'm going to go until my clock trigger, which is 0 1 is reset. 0 0 no change. 0 0 no change. And 1 0 is set. So this is my output. So you need to do one by one. It's having too many steps, but please make sure you slowly done it and you can get the answer. So this is the answer. So try to do it slowly, step by step, then you can get the answer. So this is just extra notes for you. You have master / flip-flop, which is JK flip-flop example. You can use this also for your group project later on. But I'm not going to explain all. Later, we will try to discuss for your group project. So any question related to your synchronized and unsynchronized things for the flip-flop? Is it clear or not? If there is no question, please use another 30 minutes for you to discuss with your friend. Go to Google, finding a scenario that you can find, the example, what else? Just pick what example you want or what scenario you want to do. Don't use this time for you to play around. Meet your friend, do the group back, WhatsApp group, maybe you already dismissed. And for those who still did not submit your lab 2, please contact me, okay? For lab 1, I'm not going to accept anymore. I'm going to consider only for lab 2. Okay, any other question? If there is no more question, I'm going to share the QR code for the last time. For those who already scanned, you can leave. Thank you and stay safe. Bye-bye.
Doctor,
Yes, yes.
I had a special condition back in November, and I just had to submit it maybe 1 or 2 days late, and I informed you on WhatsApp. But then I discovered that 1 week ago, it didn't submit correctly because I exited before the video uploaded on the e-learning. So I went there and submitted again because it didn't reach e-learning. The lab one.
I received your WhatsApp, but I still thinking to consider it or not.
Well, you can. I mean, the date is there. I did do it on 14 November, but it didn't really submit. Like there was a problem with the submission. So I had to submit it like last week.
Okay, later I guess today quite busy. Later I'm going to reply WhatsApp.
All right.
Okay. Who else? Any question? Any question related to your lab or maybe your module?
Doctor,
Yeah?
do we have the exercise like the test one last time?
Exercise for test 2.
Yeah.
Okay, I will try to find previous past year lab test 2, and then I'm going to share with all of you in WhatsApp group. If I did not remember, please WhatsApp me in WhatsApp group. Can or not? Don't PM me personally because sometimes I miss. So it's better for you to ask me and remind me in the WhatsApp group.
Okay, thank you, doctor.
Okay, thank you.